disable that in OBS
I
as
can
well
do it
then.
from OBS, yeah.
I see.
Okay. We should be live now.
Mm, yeah, okay. Try to.
Oops. I have you on full screen now. Okay. I'll retweet to say
All right. Are you tweeting already?
I'm tweeting from my handle, yeah, but you should as
Okay.
well.
Yeah, I can
Did
just
you get the
retweet
link?
and
Because could you drop me
yeah,
the link on Signal? Because I can't find it.
one second
Thank you.
in the group chat. And then why is that? I think we have the try, then the okay. I don't do anything about this. And am I? Yeah, okay, great. I'm not logged into Twitter on my MacBook on the Polar Signals Twitter, but I will do that, and then I can retweet from there. Actually, I can just do it from my phone. Easier, way easier. Are people able to find us? Is there anyone
Yeah.
in chat yet?
Yeah, we've got Tamara. Since we made some mistakes, let's give people a couple of minutes to join.
Yeah.
Did you also drop the new link into the old chat?
Yeah, I looked, the chat was gone, but I put it in the comments below the one.
Okay.
So, yep.
We've got someone watching from the gym.
From the gym. Yeah, great. Work from the
Awesome.
gym.
Glad to have you. Oops,
I
I'll
hope
minimize.
I hope people can't tell we've both been to the gym in the past 24 hours and somewhat tired.
We'll
So
make it work.
but don't forget about the actual workout. Tweeting. Welcome to the live stream where we will stream us tweeting. Boop. And then I will retweet this.
Can I see from OBS somehow how many people are in the chat? Because I can.
Yeah, I don't know how that works because I never signed into YouTube from OBS. But
Participants, I need to specifically click on it.
okay, I see. Oh, now I'm overlaying the chat on stream.
Are you? Oh, okay. Then, oops. Here we go. Cool.
That works super flawlessly.
Except that we needed to start a second stream.
Restart the stream.
It is interesting that we couldn't reuse the previous one.
Right? Yeah. I would assume that somehow would work, but I wonder what happens if you like lose the connection while streaming and then you need to like restart the stream.
Yeah,
I
it's
think
got to
there
work
has to be
somehow.
a way that would be super weird.
Yeah.
Right. Let's see if others are here.
Stream hopping. Yeah.
Ah, okay.
Okay.
Ooh, Kemal made it over
Kemal
from the
made
other
it as
stream.
well. Cool.
So let's see. 7 people watching. Hello, everybody.
Hello, hello.
Say hi in chat. Super blurry, my green screen thingy.
Hello, hello. We've got some more people joining. That's awesome. Some familiar faces. That's cool.
2 sources of audio and OBS. Interesting. I don't think we have that.
Sorry?
Like you have an echo, someone is saying. Mark, actually. Hey, Mark. I don't think you have 2 sources of audio in OBS.
Let me check.
Kind of
We can do live OBS
debugging.
Definitely still noobs at this. I guess he might actually be right? I have the Yeti mic here and here.
No, that's just the volume control
Okay.
in the audio mixer. So if you remove the Yeti on the left-hand side, it goes away there as well.
I see.
You could try turning down the volume maybe slightly. I don't know if that would work or help.
Maybe that helps.
That's probably way too much.
That's
Probably
too much?
like
Okay.
10% down only.
Mark will rely on your feedback here. All right.
I think is it like the noise suppression? It's not an echo, it's just the noise suppression.
Yeah, Matthias joined through a Google Meet, and I'm here with my mic. And so I think there's probably going to be a difference in quality between Matthias and my voice. I could also turn on some other modes on my mic itself. I don't know.
No, I think that's fine. Like it's interesting through Google Meet, it definitely sounds normal, whereas like it sounds super raw and uncut on stream.
Yeah. Alex, do you have a suggestion which mode would be best on the Yeti mic?
I'm using one as well, so I think it's the post-processing in the software, if I'm honest.
Do you want me to remove it?
No, I think we need to increase something there. So maybe let's quickly look at the filters of the Yeti and see what we.
We've got noise suppression. That's probably okay. Maybe
that one is okay. And this one
All right.
is a 1 or 2 to 1 ratio on top. I don't think it's a.
I also changed I applied Alex's suggestion.
Nice.
I am now using cardioid. Does that sound better? Sounds better.
Oh, interesting.
Okay, cool.
Cool. Okay, nice. Which one is that? The one that looks like a heart.
Much better.
Yeah,
okay.
I think I actually have it on that one as well.
All right, cool.
Good to know.
Good to know.
Learned something already.
Awesome. Let's see how many We've got a couple people. That's awesome. Maybe we can, since we did the stream hopping, we can give people another couple of minutes, but otherwise we'll get started maybe at 25.
I put it in the Discord and stuff. Let me distribute the stream there.
Maybe let Bill know as well. I know he said he was gonna want to try to join.
Yeah, I'll do that.
I'll also reply to the original tweet with the link.
Yeah, that would be great, I guess. Cool. Don't think. Right. I guess we can discuss what we'll do at least in a bit, and then slowly start checking out the project and stuff.
All right. I think I replied to every single tweet that people may have looked at. So I would expect people will probably be able to see it from those. Or maybe we can ask for folks who did make it to the stream. How did you find the second? How did you find the second link? Was it on Twitter? Was it on Matthias's comment on the previous stream?
I'd be surprised if someone saw it on the previous stream in the YouTube comment section.
Kemal refreshed the YouTube live tab. Yeah.
Ah, that's smart.
That's pretty smart.
Yeah, I mean, if you want, go ahead and subscribe, and then you get notified for the next chats in the future of live streams, I want to say.
Yeah, first link on YouTube and second. Okay, that's cool. That's good news. At least people can still find their way, even if going through the initial link. Smash that like and subscribe button.
Exactly. Don't like the notification bell, right?
Yes.
And our sponsor. Everybody has a sponsor. Like, just starting that line, everybody has a sponsor in their head already. Quick word from our sponsor.
Polo Signals.
Yes, I guess that's true.
Club Mate, definitely an enabler.
What did you say?
Mark said Club Mate is our sponsor.
Right. Like right next to me, I have it handy. So it is somewhat true. Decent espresso. It's still pretty decent, yeah.
Well, no, I think they maybe they're referring to
they
my
know
coffee
more.
Machine.
Yes.
I happen to own a decent espresso coffee machine. It's
someone in chat knows about the espresso machine.
I'm not affiliated with them, but this coffee machine is very nice.
Club Mate, I subscribe. Yeah, that's smart. I mean,
All right.
Next stream, I'll bring the yerba mate. I just bought the like real tea and like hot water yerba mate, so we can like switch it up. Not only club mate,
Now you're a real
but
hipster.
also now it's getting serious.
All right, cool. I guess I'm gonna wait for the 25 to hit, but we'll get started in a minute then. Did you write
Everybody,
to Bill?
yes, I just send it on DM, Twitter DM.
Cool.
Everybody excited for the weekend? Thank God it's Friday. TGIF. Put it in chat if you are.
All right. I guess we've waited long enough now. Maybe we can get started. What do you think, Matthias?
Let's do that. Sorry,
Right.
it was just...
Cool. Welcome everyone to our first stream. I think it's super exciting that we already have a bunch of participants here. Very cool. So yeah, this has really been kind of an idea that we've been floating around for some time, and those of you who may know Lily, she's an advisor to Polar Signals. She suggested that we should kind of show people a little bit more how to use continuous profiling and make some real changes and informing some real changes. So that's ultimately what we want to do here. I think a lot of you may have probably, or maybe, I think Twitter is probably the only thing that we actually use to get the word out for this. So probably you all heard about this on Twitter. Maybe then you also saw that I asked for suggestions of what we should profile today. And there were a bunch of really cool suggestions. But I think one that kind of stuck out because we happen to use it in our production infrastructure at Polar Signals, and that's the Cilium project. For those who may not be aware, Cilium is kind of this networking layer so that, for example, in a Kubernetes cluster, your containers can talk to each other even if they're on different nodes within your cluster. So yeah, that's kind of the intro. And what we're going to do is, since, like I said, we already have our production environment, we're already, obviously, Polar Signals is dog fooding the product itself a lot. So I guess we can kind of just dive in and show the product a little bit. For those who are maybe familiar with the open source Parka project, this should look pretty familiar. Essentially, Polar Signals Cloud is just the Parka project, as a SaaS product, the way that you're probably familiar with. Yeah, so we'll kind of take a quick tour around, and then I think we'll dive right into it. What do you think, Matthias?
Sounds pretty good. I think I can actually mention that like profiling this not only makes sense for our cluster and infrastructure, but like I think it's like on all major clouds. At least Cilium is offered by now. So basically, whatever we can find today, hopefully we can upstream, and then it will be on all clusters.
Yeah.
Oh, that's my uncle. Hello.
Yeah, hopefully by improving, Cilium that runs on all major cloud providers, we can actually have a real impact on the world today in reducing CPU cycles around the world. So hopefully we'll be successful at that, right? We don't know yet. While we've done a tiny amount of looking into, what could be interesting to profile, we have no idea if we're going to do anything useful today. Should be fun though.
We'll try our best.
Of course, always keep feel free to drop anything you're maybe interested in or any questions you might have. Drop that into the chat, and we'll do our best at answering that. Last thing, Matthias, I think you had some ideas to add some background music. What was that
Mhm.
noise? What was that website again?
Let's see. It was.
I'll
I
put you on
wasn't
the screen
prepared for
for a
this.
second. I think it's like lo-fi or something like that.
Lo-fi cafe. When did I send this? Yeah, lo-fi.cafe.
Lo-fi.cafe.
Since
Okay, I
since
got it.
since when is cafe a TLD top level domain?
Oh, that's pretty loud.
I think you know what you need to do, Frederick, right?
What do you mean?
I think you need to get your GitHub handle.cafe as a domain.
Sounds good. All right. Let's see if do people in the chat hear the background music? For me, the chat disappeared now.
Yeah, that works. I just double checked on my end. But I'm gone. At least instead they see the lo-fi cafe now.
Actually, that was my bad.
If you can change
I think you should be back
tabs,
now.
then. Woo! Thank God.
All right, cool.
I'm real after all. I'm somewhat of a ghost though. Like I'm half translucent, so.
So maybe before we do anything else, what we've got deployed in our production cluster is nothing different, or actually it's exactly the Parka agent. So the way that this works is that you just have this agent that you deploy, in our case, onto our Kubernetes cluster. But all you really need is a somewhat recent Linux kernel to do this. You don't have to have Kubernetes, but if there is Kubernetes, we can attach some pretty cool metadata like the container, Kubernetes labels, and a bunch of metadata that may be interesting to filter and query the profiling data with. And it just kind of starts profiling everything that's on the host and tries its best to to send some really high quality data to the profiling storage. And that's what we can see over here. So this is kind of our production cluster. Just for brevity, this doesn't necessarily contain all of our production data. We can't necessarily share absolutely everything at Polar Signals, but I think it should be sufficient for the purpose of this stream. So as we can see right here, we could now click on any of these dots on any of these line graphs, and we could pull up the profiling data at exactly that point in time. And what we get pulled up by default down here is the icicle graph for our entire infrastructure over the last 15 minutes, right? So what that means is we're not only looking at the profiling data right now of a single process, but actually our entire infrastructure all at once. And the reason why this is useful is if we can now optimize something in this icicle graph, that actually translates into a cost saving on our CPU side, because this is actually what, in a representative way, is being consumed by our infrastructure, right? It's not just a single point in time, it's actually, statistically significant over time. So yeah, that's kind of the intro. So I guess we can kind of go right ahead and start looking at the Cilium agent, and we can look at individual features from here on out. So
what did you just do? Like you typed com, like what's com? And
great question.
So you can explain that.
Com is
also, hello Kumar. Let us know if you have any questions. Sorry, Frederick.
Yeah, no worries. So com is kind of this well-known terminology in the Linux world. We can kind of think of it as the command or the binary name that was used to start this process. So basically what I just done is I filtered all the profiling data in the entire cluster down to only looking at the Cilium agent. And that's what we're seeing here from a couple of nodes in our production cluster now. We can see all of the different Cilium agent processes that we have running. And again, just like before, by default, we get all the CPU profiling data over the last 15 minutes. We get displayed down here. So if we wanted to, for example, let's say here we can see we've got some individual data. So this was, now we're looking at only a single process, this one process on this node with this process ID at this particular point in time, right? And the profiling duration is always over 10 seconds. That's how the Parquet agent works. And so now we're only looking at those 10 seconds at a time. And the kind of last super cool feature that I think is worth exploring is the compare functionality. So finally, you know, as let me undo this actually and filter this down to a single process. So let's use this one. What we can do is finally answer that, you know, age-old question of what was different about this process at this point in time versus this spike, right? And in this case, we can see that almost all the code, we can see plus infinity, for example. That means this entire stack was not present on the left hand side here. So clearly some very different code was actually being executed. Perhaps we can find one where it's a little bit more similar, but it seems like continuous profiling is actually working because statistically we're gathering a bunch of different stacks over time. And so ultimately this kind of merged representation is the thing that's actually interesting to us. So let me remove this process ID again, and that's what we can kind of start to use to explore our data.
Can people let us know on stream if we should increase the font size? Is this readable enough? Just, is it fine? Is it too small? Does it need to be bigger or not? I think like I have it like on one side of my screen and just like slightly smaller, so it's like barely readable for me right now. So yeah, let us know if we should make things bigger, but if it's readable, then obviously we have more real estate to work with. So that would also be a nice trade-off.
Yeah.
Okay, so it's okay for people.
Cool.
At least one person says it's fine.
All right, so from
Or
here
what
on,
everybody else.
you know, the idea was to kind of, let's just explore this data. And what's actually also really cool about continuous profiling is it can kind of teach us about this workload, right? So we can see a couple of really high level stacks here. So for example, we've got the Cilium package Hubble observer. So this seems like this is probably some sort of long running process within the Cilium process. And just FYI, I have no idea about this code base, right? I'm looking at this code base for the first time myself. The only thing that I did prior to this to the stream is kind of check out and clone the repository, because as I correctly expected, it's a fairly large repository and it took a couple of minutes to pull down. So that's really all I've done in preparation for this. So let's kind of explore this. It seems like...
Yeah, maybe you can, before exploring, like people are watching on TV, so if you like make it like 1 or 2
font size larger,
font size is bigger, just like press the plus button like 1 or 2 times. Yeah.
How does this look? Okay.
I think that's perfect. Yeah.
Okay, cool. So we can
now
see,
it should be readable for everybody.
We can see that whatever this long-running thing is doing, you know, it seems like it's observing something, and it seems like it's parsing something. So that's already good. That's a CPU-bound operation. Probably parsing usually is. So there's probably something that we can optimize somewhere here. Yeah, I don't know exactly what this is. So the first kind of thing that I typically do when I start to want to optimize something, there are a couple of very well-known things that tend to bite us as software engineers. But first, I want to kind of understand this code base a little bit better. So let's look at the next biggest frame here. So this is about 20% of all the CPU time we're looking at. It's handling some sort of events. It's processing some records. It's reading some records. Again, this looks pretty good. This looks quite promising. Probably a CPU-bound operation of some sort. Read record. Binary. Okay, this is already one of those things that I like to look for. Binary read is a tricky thing in Go, and we'll dive into why that is. I'm gonna say already, this is probably one of those things that we're gonna be looking at later. Let's note that down, binary.read. Super interesting. And this is in Cilium/eBPF. Okay, cool. Let's look at the third largest one, and then we can start to dive into some of this. Okay, so we've got some sort of trigger, new trigger. I'm guessing this is a Go routine that's waiting for something, waiter. Select Go, it's probably listening through some Go channel for some events. Since the select Go is dominating this path, there's really not a whole lot that we can do about this other than if we change the architecture quite dramatically. But the Go runtime is actually fairly good at optimizing these things.
Actually, I have a question about the runtime.park right below the select Go. I think it doesn't really mean that there's like lots of CPU cycles spent or like burned there. It's just like the stack was just parked in a way at that point in time, right?
I believe so. So I'll be a little bit careful here because I don't know all the details for sure. But I believe basically, and I think the schedule function is kind of telling us this as well. But you know what? We can actually
let's read the runtime code. Nice. People were saying maybe turn down the volume of the music ever so slightly. I think it's probably because you turned down your volume on audio as well. So just quickly. Oh, even more? Maybe then turn your audio up a bit in OBS.
Turn my audio up. Is that better then?
No, for the stream, like in OBS.
I see.
I don't think.
How do I do that? Over here?
The Yeti thing, yeah. Just like go to, like this probably. And then I think you can leave the music as is.
Yeah.
As it was before.
Let us know.
The music. Okay, yeah, perfect.
Perfect.
Yeah, I don't hear it through Google Meet. That's why I always need to first quickly double check. Okay.
Yeah.
Let's look at runtime code.
Let's see. Recently reading Golang source code, found some interesting points. One of them, there's a park_m and runtime proc. And if anybody in chat knows, please let us know.
I'm trying to find it in the runtime proc Go file. Let's see if that's func park.
So park and schedule.
Yeah, it's line 3,487.
3,000.
You can just search for func and then space park, and you should be able to find. Okay, you're looking for schedule. Let's see.
The schedule function in, what did you say? What was the line number?
Yeah, it's this file. just search func space park and it should find it because there's only one. Isn't park used to tell Go routines to waiting for something, for example, IO? Yeah, I think exactly. We're just trying to figure out like what actually happens in the park thing. So
it was more learning or refreshing on the runtime
internals, yeah.
internals. But basically, the way I understand it is, it hits this select, and there's nothing to do. It's waiting. So it's kind of trying to figure out what is the next thing that we should be running, and preempts this Go routine probably and starts running something else if there's something else to be run. I would say that's probably what's happening over here. And in this stack, we can see it's waiting for a timer. So I'm going to say this entire kind of all of these stacks are probably fairly uninteresting for us. So we kind of identified something earlier already that's probably pretty interesting to look into. And more generally, we can actually use a functionality that we have here. Oops. We can kind of filter all of this data down to what's using binary.read. So let's have a quick look at the Go code to understand why this function is often problematic. Encoding. Oh, sorry, was it? Yeah, encoding/binary.
Yeah, encoding binary.
This read function, this is quite often pretty problematic. And the problem here tends to be exactly this line of code. So people who've done a lot of performance optimizations in Go are probably quite familiar with this. Because we can't predict what n is going to be, Go will end up allocating this byte slice on the heap. Whereas when we know, for example, that the thing that we're going to want to read is, let's say, an 8-byte unsigned integer, then Go could actually just allocate 8 bytes on the stack and therefore not end up allocating, which is a much more expensive operation than making some space on the stack. So this is quite often rather problematic. So I would say let's try to write some code. So let's go with this one first. Cilium/evpf perf and read record. So whoops. I'm gonna open this in my terminal. I'm gonna make this quite a bit larger.
Yeah.
Hopefully this is large enough for people, right? So, like I said, I already pulled down most of the Cilium repositories in anticipation for this. So this one was in the perf package. Let's look at this one more time. And it's the it's the reader.go. So we can use that to open this. All right, so we've had binary.read. Read lost record, is that the right one? Looks like there's a couple of occurrences of binary.read. Maybe not this one in particular anymore. Read record.
I guess it depends on which version we are running as well, right?
Absolutely. Yeah, it looks like in this instance it might already be fixed. Assert that the buffer is large enough. Read full. So we try to read the whole IO. Okay. Let's have a look. Maybe someone's done exactly this work already. So this was done roughly in May of last year. Let's see what the Perf add allow reading. Yeah. We can see this was already optimizing for allocations. So I'm guessing someone's already done the work here, but I think it's still worth kind of just for, maybe we can go out of this project and just do test binary read, just to demonstrate what's happening here and why we should kind of watch out for this.
Maybe we can figure out the version of Cilium we are running and actually check that one out, so we have like the very specific version of the code at our hand, and then try to basically do what this person has done, but kind of like do it on the stream.
Yeah, we can,
I don't know.
Can we?
I don't think I have access to the cluster, so. Which project is that?
Yeah, no, this is actually in our production project.
Oh, okay. So maybe I can assist you with this. Let's quickly look for Cilium.
We could also check if this other one, Cilium package monitor, if this maybe still has the problematic binary.read, even in latest.
In which pod is that? Net
it's not a pod. So if we look at this, oh no, I'm wrong. It is
Cilium agent in pod.
It's ANET-D.
ANET-D. Yeah, okay, that's why I'm not seeing this. All right, so I can see Cilium agent in that pod is Cilium version 1.11.7. I will just post that in the chat so we have it somewhat persistent somewhere, but it's 1.11.7.
Data path trace is the
yeah,
other.
You can find that.
Perhaps there is still.
I'll try the other one, you think?
Yeah, I'm trying the other one just to see. So we've got decode, trace, notify.
I think you just opened NeoVim and the stream froze for a second.
Sorry, yeah, I used NeoVim. What?
Yeah, no, when you opened it, like at the same time, the stream froze for a second because I think there was.
I see.
CPU. But it shouldn't happen too often, so.
Hopefully not.
That's the first time seeing this.
All right, so this may still be interesting. We've got a reader and trace notify v0 and trace notify version 1. Let's see what this looks like. Trace notify. It's got an IPv6, which is a 16-byte. Oh wow, this is a fairly large struct. But at the same time, it's all just relatively small pieces of data. So this may actually be a pretty good case to optimize.
Let's check it out.
So data path trace.go. Let's open the test files. Maybe there's already a benchmark. Looks like there is not. All right. Let's see. I would suggest maybe what we can do is we extract this into two separate functions. One for the case where we have trace notify version 0 and one where we have trace notify version 1. And that way we'll have a little bit easier time kind of benchmarking this and writing a micro benchmark. So let's continue with the terminology here. Decode, trace, notify, version 1. And we've already got a byte slice, so this is actually potentially an additional allocation here. Actually, let me look into this. Actually, this is this is for sure an additional allocation. So we're actually already getting rid of an allocation just by operating on this byte slice directly rather than using this interface. This can be tricky, especially when working with performance. It can be very easy to accidentally allocate, and it turns out humans are spectacularly terrible at estimating how code behaves, and then you get something like this as part of the runtime that allocates by default, and it's very easy to start adding allocations accidentally. All right, I believe in version 1 we had version 0 embedded. Is that right? Do I remember that correctly? Trace notify v1. v1 includes v0. Yeah. All right. Then let's maybe rather start with version 0. So we want a pointer to a v0 struct. And of course, we do not want binary.read. Although actually, that's not true. We want to, for benchmarking purposes, we want to be able to do before and after comparisons, right? So let's do that. Let's first implement it with this. And we do that by replacing this. No, unsafe pointer. Copilot, GitHub Copilot wants to make me do some pretty unsafe things here. Let's not do that. Decode. Turns out AI is not perfect. And we've got data. I think this should work. Let's run some tests to make sure that this works. I'm hoping this doesn't have a Linux dependency. It looks like it does not. So I'm gonna trust the Cilium developers here that they've tested this class pretty
hopefully
extensively, and if not, hopefully we'll get some reviews on a GitHub pull request. All right, so let's now start writing a micro benchmark for this function.
So Alex says in chat that Hubble is the observability facility of Cilium, and Cilium eBPF is the data path that emits events from the kernel, which are then read by Cilium agent. So that is kind of what we're dealing with here. And I guess the data that is being read is the byte slice that we need to decode, and that happens a ton in the code, I guess.
Yeah, that makes sense. All right, so maybe for a start, actually what we can do just to get things started, we can use an input that is a tn dot trace. Sorry, is that the type as well? It is. It's trace notify 0. What is tn? Ah, no, we're we're in this package already, so no need for this. This is our input. This already contains all of these things, so we can actually just to produce our data for this benchmark, we can use binary. We can use the binary package and use some of these helper functions. I think there should be a opposite as well. Yeah, so we've got the write function as well here. So we're going to use that to just produce our byte slice that we want to use for benchmarking purposes. So let's do binary.write, and it wants a buffer, of course. And what does this return? Okay, so we need to first have our buffer. It's the buffer. We'll use this byte order native, which is something I saw being used all over the place here. So we'll use the same thing, and we'll marshal our input, and all it looks like this is. Let's just have a quick look at what the conventions in this repository are in terms of testing. Oh, interesting. I've never seen this. What is this?
This year.
Check v1.
It's like a helper thing.
Yeah, looks like it.
I actually haven't seen that before either, yeah.
Interesting. Let's check that out for a second. Maybe there's something specific that we need to adhere to write a benchmark. Whoops. Check. Testing. Sweet. Let's just search here. Okay. Looks like,
I guess it has like the reset timer and a couple of things that the benchmark has under the hood as well.
Yeah, that's what it looks like.
Yeah.
Okay. I've never used this, so there'll be a learning curve here, but we'll figure it out along the way. So let's see how this is done. Monitor test.
Generally speaking, I think we can also use the other one for now, no? Like the normal Go benchmarks, and then
that's fine, and we can figure
make
it out
that an
later.
offline thing to convert to this one. Your choice, I guess.
That's fair. That's fair. Let's stick to the things that we know, and then we can adapt it to the tooling. That's fine with me as well. So what we're going to do then is if it's now p.fatal we're going to reset our timer. We're going to, yep, you want to suggest that again? Yep, there we go. And then, yeah, we want to do that. We're not going to test this for correctness for a second. We can write a correctness test in a second as well, but for now, let's just make sure that we call this function specifically, and we use the bytes. Yeah, that's good. And we need to, what does it want us to do? Cannot use variable. Notify v0. All right, looks like we've got a benchmark. Let's try running this benchmark. In case you're not familiar, we need to pass, if you don't want to also run all of the tests in Go, you need to pass this run flag. And what we're just saying here is passing a regex that ignores pretty much everything, because this would only match an empty string, which is impossible to have as a test function. So it's a bit of a hack, but it does the job. So we can see this is kind of our before result, right? So we're gonna want to save this old.txt. So this is what we're going to be benchmarking against. So just to make sure that we have enough significance here, and we can check this in as a checkpoint, so that we have this test already, so that we can use git to undo our changes if we need to. All right, we'll commit here. Perf dash, what was it called? What was the function called again? Decode trace
decode trace notify. Yeah.
Oh. Perf decode trace notify, and we'll add these. So we'll be a good citizen and write a git commit message. We're in package monitor, add benchmark for decode. What was it again? Trace notify v0. All right, we've got our baseline. So now we can start to optimize this.
I wonder how many people in chat have written benchmarks before. I think it's pretty common, thankfully, in Go to write them here and there, right? So actually, I don't know, let us know.
Yeah.
Sorry?
Yeah, no, I just wanted to kind of show some more data to prove that this is the right thing to go into, right? We had the we have this CPU profiling data that we originally got from our continuous profiler with Polar Signals Cloud, and now let's see if in this micro benchmark, the same problem that we anticipated with binary.read to be problematic, right? So let's do that. I think we're not going to need multiple counts. We want a mem profile, mem.prop. The reason why I'm looking at a memory profile here as opposed to a, whoops, what happened here? Unexpected 32-bit segment. Interesting. Does that only happen when we add the mem profile? Okay.
And that's unfortunate. Interestingly enough, it worked like with count 5 above, right? Without the mem prof. That is very weird. I've never seen it fail for enabling memory profile so far.
Me neither. That's maybe something to dive into another day. Let's see if with CPU profiling this happens as well. Fascinating. I'm going to guess this has something to do with Go compiling this this test to run it like this. Maybe there's something about it there, or maybe something Linux specific is now actually shining through. All right, we'll need to trust our gut here for a second and see if we were right or wrong, right? Like let's see if our theory was correct or not.
So the memory and CPU profiles would have shown hopefully the same thing we've seen on Polar Signals Cloud with the continuous profiling, right? Just show up in this specific micro benchmark, so we can verify that we were able to reproduce this locally.
Precisely. So, but the way that we can still verify whether this is ultimately going to work out is we'll see hopefully an improvement on the benchmark itself. So that's still good enough. It would have been nice if we saw the same pattern that we saw through the continuous profiling data in local profiling data. But like I said, we'll need to trust our gut for a second here. All right.
Do you think it makes sense to enable the reporting of allocations in the benchmark, given we don't have a profile in this case?
That's a good idea. That's a good idea.
Could be another signal we can use below
Do you happen to know the
you can I don't know the flag. I actually always put that in the Go files in the test in the benchmark file.
It's the
so you can above the what's the
I think it's here, right?
Report
it's like,
logs.
B dot.
Test. Yeah, report logs. You can just put that above the reset timer.
Let's run that again.
Yeah, exactly.
Okay. That it doesn't like either.
You ran with the CPU profile.
Whoops. Good catch.
You want to run with the count 5, I guess, that one.
Let's first see if it works. Okay, so we've got 3 allocations per op. That's already pretty low. So
yeah.
there may not actually be something that we can optimize here. But let's still give it a go, just to have a look at the methodology of the TXT. Still, 3 allocations. If we can get it down to 0 allocations is always going to be faster than 3 allocations.
No more heap.
And we did see this these stacks in the continuous profiling data, right? So these are actually being called pretty intensively, clearly. So if we can get rid of these allocations, we will still make a real change. All right. We've got our function. Now let's take this apart. What I'm going to do is I'm going to take all of these and copy them in here so that we can kind of go one by one and use byte order dot, we can do that like this, byte order dot native dot, and then we'll leave it like this. And each of these is just tm dot, could have done a fancy Vim trick here, but we'll just roll with it. Now, uint, of course, that uint 8 actually that doesn't need any decoding. That just means data 0. GitHub Copilot already knows what we want to do. So now it's probably the first time that we actually are going to decode something.
Maybe you can quickly explain why data 0 works in this case with the uint 8 and stuff.
Yeah, that's a good question. So people, let's undo this for a second here.
We've done like time series database stuff, right? But other people will not be as familiar.
So yeah, let me undo this here for a second again. So uint 8 is just 1 byte, right? And so whatever, there's nothing to decode here, right? There's a slice of bytes here, and what we would just say is decode the first byte. but that just happens to be the first byte. So it's kind of a no-op. So we can immediately just go ahead and say, I just want data 0. And we can do the same thing over here. And source, like we said, is a UN16. We can see GitHub Copilot already. We could, I'm going to type this out manually, but we could probably just have GitHub Copilot do this because it's very repetitive. It knows how to autocomplete this. Actually, let's have a look if it knows that this should be a UN32. It does. And it does even the offsets correctly. Let's try this again. UN32.
I recently enabled the GitHub Autopilot on some of my things. Like I'm very late to the party, and it reminds me a whole lot of like the Excel autocompletion in some way.
Yeah.
Because it's like sometimes it thinks things are different than what they actually are, meaning like referring to the dates in Excel, right? Where everything's a date. So sometimes it reminds me of that, but it's pretty impressive how it gets things like these repetitive things correct.
Let's see what this is. And we've got a UN32. So we're gonna need to do a something slightly different for this one. But even that, GitHub Copilot knows exactly what to do. Very cool. So let's do that same one on destination label. I guess we've proven by this stream and us talking through what we're doing here, we've proven that there's no trademark violation happening here. We knew what we would need to type out. We've verbally confirmed this in case anybody thinks that this could be an issue. So we've got a UN16 here again. So we're going to do our byte order. Yeah. Whoops. No, it's correct. Yeah. And now we've got a UN8 again. So we can do the same trick that we did up here. Data 26. That looks right. This one will be data 27 then. And lastly, our last 4 bytes are going to be this UN32. All right. Now we don't need this anymore. And there's not even an error anymore. But I'm going to just keep this error around for good measure because I know what we'll do with it later. But we can already see this function should not be allocating anything anymore, right? The only thing that this function at this point is doing is it's reading from this byte slice, right? At best, we're doing some, we may be doing some kind of bit manipulation within this byte order encoding, but all of that would happen on the stack where we know exactly what sizes of data we're working with. The one thing that we're going to want to watch out for is that we don't have any index out of bounds, right? Previously, that would have resulted in an error. Here, it's going to result in a panic. But we're going to set that aside for a second and just check if this is going to be faster.
Where does the allocation then actually happen? I mean, previously we had allocations in this function, but somewhere we need to allocate things, right? And you can quickly go into this once you've run the benchmark.
Mm-hmm. So now we've run the benchmark again 5 times, and we've put it into this new file. And you know, if you remember what this was before, I can already see that we did improve the performance of this quite dramatically. But just for good measure, let's do the good old comparison. And it looks like, you know, we've removed all the allocations clearly. The allocations now says 0, and we've made it 90%. Not we've cut down the runtime very significantly here, right? By 91%. However, like I said, what we should make sure is that we would still error on the on similar problems as before, right? Before, we also didn't know what we're decoding, so if what we're doing here is garbage, then that doesn't really change compared to previously. But what we're going to want to prevent is that we panic in this. And so, this is a nice suggestion. So if the length of this data is, this is what GitHub Copilot is suggesting, if it's less than the length of our trace notify v0 struct, then we should return an error. In this case, let's actually not immediately use this constant. This constant is not actually defined anywhere, so we're going to use, what is it, 32, and say return, it's not unknown trace event, but we want to say unexpected length of data to decode into trace notify v0. All right. Actually, we're not templating anything here, so let's just do error stuff new. All right. This is already looking pretty good. So I'm going to run another benchmark just to see if this, we're doing more work. This should be more expensive than previously, but hopefully still significantly faster than before we've made all of our changes. So once again, this was our first change. Here's our change afterwards, and it looks like we've even gotten a little bit faster. And we may even have an explanation for that, but let's just look for a second here. That's interesting, right? We've made it significant, or not significantly, but we've definitely cut down again by 6% the runtime. So why did this happen? Right? I think I have a theory. Basically, what we're doing with this is we may actually be introducing, we're doing something very implicitly to the safety of this code. What we're checking here already is that all of these accesses down here, all of these that could potentially panic, where what we're potentially doing is we may be eliminating something that's called a bounce check and go. So basically, because we have this if statement here, and we would already do an early return if this data is has a length that's smaller than 32, then we're kind of just immediately going out of this function again. What that means is once we get to all of these, Go doesn't actually need to do the check that would actually cause the panic anymore, because we have verified that this up here is ensuring that all of these accesses down here are going to be safe. The way that we can verify this is by additionally adding something. GitHub Copilot already knew what I was going to do. If we can access the element with the 31 at the end, that hints to the compiler that we no longer need to do bounce checks for each of these. So yeah. What that
I love that it knows about the issue number as well.
What that should mean is that now that we've added this additional line, we should not see an additional improvement. And if we do, then we should actually even have a look at the assembly code that is being generated for this function. So let's have a quick look. and do yet another benchmark run.
I hope that's the comment you were hoping for, Alex. Alex said that we should add such a comment in the struct, or I guess close to where we decoded. But was that the comment you were hoping for? Let us know. Then we can eliminate one iteration in the PR already, I guess.
Yeah. So as we can see, this does not give us a new saving. And just to check that this, we could look at the assembly code itself to see if the bounce check, or we could also run go test in a way that we will actually see the compiler hints if we don't want to look at the assembly code. But what we can just do real quick here is just comment this out for a second, because that means we should still be getting the same kind of performance that we were getting before. So hopefully for the last time now, we're running this, and we should again get exactly the same result as in new 2, new 3, and new 4. And we should still be, identical. Whoops. Comparing new 4 with new 4 doesn't really make sense. Okay, this is so small that I would say there may be a variance about like the cache instructions miss, right? What that would mean is if we have this code, we actually have an additional branch that the code may need to jump into or out from. And so therefore, this code is actually more complex than this code. And therefore, I would expect this to be very, very slightly faster, right? We're ultimately doing less instructions. The CPU needs to load less instructions. I'm not going to look at the assembly code here, but I'm fairly sure that's what would have happened here. So in this
do
case,
you think it's
do
you think it's worth like not including the if-len data? Yeah, that was my comment. Like, I think it's nicer for safety reasons, right? And error checking.
I would keep it for safety reasons. Yeah. Something that I think we should probably do is move this function close to trace notify v0, perhaps even attach it to that function, to this struct, as then hopefully if anybody ever changes this, although as we can see with this, we actually this is versioned, so it seems like whenever there is a change, this is going to be updated. Maybe if we have some of the folks from Cilium in the chat, they can let us know what their preference is, so we don't need to defer this to the pull request. Otherwise,
yeah, I'm laughing because we already got the comment that like we should add the comment on the struct that it would be nice to have this noted that like the decoding needs to be updated if the struct changes.
Yeah, I was also thinking of this. First, let's finish this function though. I would say let's add a comment here to say that this also eliminates the bounce check, right? This eliminates the bounce check in the accesses to data below. Yeah, let's leave it at that. All right, and what do you think? Should we attach it to the struct or make it a separate one? I'm undecided.
Yeah, I don't have a real preference either, if I'm being honest.
I guess this is an unexposed function here, I think I would prefer to attach it to the struct,
that works.
since it's only used within this package anyway. But I don't feel strongly about this. If there's a preference by the Cilium project, maybe there's an established pattern to do this, then I'm more than happy to adapt it to whatever the preference is there. All right, so let's hop over to where this is defined. We can have that over here, and cut this out, put it over here. Save this. We still have our definition in here. Actually, this is the same file. It's both data path underscore trace. So we're just moving it closer, which I think does also make sense. We'll bind it to this struct, trace notify v0. Now we can remove it from here. Whoops. Decode trace notify version 0 decodes. Yeah, I'm happy with this. Into the struct. This function needs to be kept in sync. Yeah, exactly. Not with the C struct, but kept in sync with the struct above.
The C struct?
Just for, yeah, this is it's not uncommon if it's a C struct. So what GitHub Copilot is kind of identifying the pattern here is that if you're reading some sort of unsafe set of bytes from that represents a struct in C, which is, everything in a computer is just a slice of memory, right? A slice of bytes. So it's not uncommon, for example, if there is a cgo extension, that you need to do something like this. Okay, GitHub Copilot already knew what I was going to do here. This struct needs to be kept in sync with not with the function. This is the thing about Copilot, right? It's very good. It's a much better auto-completion, but you still need to pay a lot of attention to the things that it's actually generating. To me, it's like, a much better auto-completion, but definitely you still need to pay a lot of attention. The struct needs to be kept in sync with the function below.
Yeah, Alex actually mentioned that in chat, that the structure, like the slice we are decoding, actually comes from a C struct that's associated on the kernel side, right? So it kind of even makes sense in that comment, but I think it's fine the way we've written this now. Julian, hey, nice to see you around. I think he wants to know what criteria you use or we use for deciding whether a func should be attached to the struct or not. So I guess method or function, when to use which one. I don't know.
I don't think I have a perfect rule for it, but if I think there's a pretty clear pattern that if everything that happens in the function is an action on one of the parameters passed here, I feel like, if this is also contained within this package, I think this was a pretty natural one to attach it for me, because it's an unexposed function. It's not an API of this package, and it's only ever used to decode this data into things within this struct. So I don't think there's a hard rule, but for me, this definitely passes my non-hard rule for deciding it.
Yeah, I agree. And I think, like, still after years and years of writing Go, there's no like definite rule of when it should be one or the other. Like, it always depends on the specific case, but I think your statement was like well on point for this one. I think actually now looking at the function or the method name, I think we can actually just call this decode because it's like in the struct name already, the rest of it.
So I think I would, let me talk you through what's going through in my mind. So if we remember the place where this is called, right? This sometimes is trace notify, where we explicitly need to do dot trace notify v0 because this is an embedded struct, right? So we would need to be kind of careful here if we attach another function to this method, another function to this struct that we also call decode, that we are actually calling the correct thing. Do you understand what I mean?
Yeah, it's I think it's like slight anecdote. I think that was like one of the interview questions you asked me in my interview at Red Hat Chorus almost 4.5, 5 years ago, which is like the struct embedding, right? And like you need to explicitly give the embedded struct name and then the decode. But yeah, I guess then if we don't do that, then we can get around this.
Yeah, I think it's very easy to do the wrong thing if we called it decode here, and I would agree that if there wasn't this this problem, I would probably also prefer to call this decode. But because we have this potential name clash and it's not an API of this package, I think I'd rather do the thing that prevents me from doing the wrong thing.
Yep, fully agreed.
All right. I think we're golden. We need to update the call site. So tn dot trace notify v0 dot. Interesting. Do we need to do this dereference? Isn't this already a pointer? Do you see what I mean? Like, do we actually need this? I'm curious now.
The live stream is like slightly slower. Yeah, I think you might need to do some dereference maybe to tell without. Right. But we don't need to pass the struct as an argument, right? Like that's gone.
The thing is, if we just do this is the struct is embedded, right? So if we do this is a pointer, right? I think what they were maybe this used to not be a pointer or something, and they needed to change it in place anyway. Although that would be interesting, because the caller would make a copy and pass it down. I'm not exactly sure, but we should, if we write some correctness tests, we should make sure that this actually behaves the way that we do. This might bite us in the and we may actually need to do this, but we're gonna skip it for now and defer this to our correctness tests. All right, let's see that overall tests are still running. Undefined decode trace notify. This is our benchmark. So of course our benchmark needs to be updated now that we've changed the API of this. All right, let's run tests. Test pass, and we can do one final run of our benchmarks. Let's just verify. It was about 16 nanoseconds. All right, looking pretty good. Looks like we even got a little bit faster. That's interesting. Let's see if there's some significance to that improvement.
All right, Alex has to drop. Thank you for hanging out and giving us some feedback and comments, so we can do this in one less iteration on the PR.
Yeah.
Bye.
Let's see, U4, U5. Interesting, but this is so small at this tiny micro benchmark. This may be something within the tolerance of CPU frequency changing or something like this. I don't know if there's a real change here that happened. But let's compare our. So we've made things. Yeah, I mean the percentage hasn't really changed. We've made it. About, what is that? 191 divided by 15. We've made it 12, 13 times faster. Not too bad. And if we say it in percentage, we've reduced the runtime by almost 92%. Not too bad for something that we were thinking for some time that maybe we won't be able to do anything. All right, I think we have kind of a couple of things left to do before we can open a pull request with this. We need to also finish decode, trace, notify version 1. There was that additional version. So I would say let's write a benchmark for that one as well. So we've got version 1. Although before I do that, actually, let me delete that one more time. And let's commit what we've got. It's looking good. All right.
Very nice. Yeah. Yeah, I think that's great. I'm just looking at the profiles again, like how much percent that would be that we saved. Oh, Manuel is also on the.
Hey.
What's up? For data access and memory alignment, does it matter how you order fields in a struct in Go, or does the compiler optimize that?
That's a great question. Go does actually do a little bit, so it may do some alignment, which is why actually the binary.write that we did there may not always be safe to do, because Go may be adding some padding in places. But it's a really cool question. There's this tool called, is it struct align or something? Golang?
Yeah, I don't recall that exact name either, yeah.
Field alignment. Field alignment, yeah, this is the tool. Why do I keep getting this notification today? So this is kind of this a pretty neat little tool that you can use and run on a Go struct, and this tool will analyze if there's a better way to lay out your field in order to use less memory ultimately. So maybe we can even give this a try. Let me just finish this commit message, and then we can run it on this package and see if there's potentially something that we could improve. Great question though. So improve performance of decoding.
Yeah, I know that, like in Prometheus, this definitely had some impact as well with the field alignment.
What was this thing called again?
Decode, trace, notify. Decoding, trace, notify. This one.
And we'll include our benchmark. We'll include our benchmark in here. Would be nice, and write a good commit message. Previously, decoding trace notify v0 allocated performed multiple allocations.
3 actually, you can you can tell from
3 allocations, 3 unnecessary. Is that correct? Is it with 1n, 2n? I never know. Unnecessary? I think it's 2.
Yeah, I hate that word.
2 n's apparently. That's what Google says. Previously,
Yeah,
decoding
2 n's,
trace notify v0 performed 3 unnecessary allocations. This patch removes these allocations, resulting in a roughly 92% performance reduction in runtime performance. All right, that looks pretty good to me. Let's commit that.
Yep.
And
interesting.
Sorry?
Manuel wrote in chat that it looks like Golang CI also has like a I think it's part of the GoVet plugin there that it can check the field alignment. So you can even do this in TI. Pretty neat.
Yeah, it looks like replaced by GoVet field alignment. Yeah. Very cool. We're all learning. Thanks for thanks for the shout out. All right. Do I have it installed? I do. Cool. How do you use this thing again? Field alignment finds structs that would use less memory if their fields were sorted. This analyzer finds structs that can be rearranged to use less memory and provides a suggested edit to the most compact order. So I believe we can just do field alignment doc and it should do the trick. So we've got a suggestion for maybe this is the struct that we're working on. Data path trace 308 struct of size 144 could be reduced to by 8 bytes. So you know that could be significant.
Can you run this again and clear your screen, because we're like overlapping on stream. People can't read that.
Is this better?
Yeah, I think that's definitely better.
All right. So let me call up these the help text for this thing one more time, just because I want to know. There was a flag where it would print the suggestions. I feel like. I don't see it. Did it maybe just? No, it didn't.
Or you can do the dash fix automatically. Yeah, I don't. I think maybe dash source, which is deprecated, but maybe that one.
All right, let's just give it a shot, right? And just fix everything. Just for, you know, we have a clean working directory. We can just check out everything again, no problem. So we've got field alignment dash fix dot. So we should have a bunch of changes now. Very cool. Let's check if data path that trace. Looks like it's a different. It's a different struct, which was not the one that we were working on. So it looks like if this one is not a reflection of a C struct, that may have some implications, right, in terms of the order, because things like binary dot read or write, it actually uses the order, I believe. Though I'm not 100% sure, but I think that's the case. So yeah, I think this could have a real memory saving. Though I think we're gonna try to stay on track here and just improve the decoding of these version 0 and version 1 struct, as that's exactly what we were seeing in the profiling data originally, right?
Maybe you can copy the name of that struct and see if it even shows up in the profiles to begin with. Like the one it just realigned. No idea.
Yeah, we can try. Let's remove this for a second and pull up the most recent data. Yeah, looks like we can find it, but what field alignment does is not necessarily CPU related, right? It reduces memory, and so that's not something that we will see from CPU profiling data. Let's go back to what we had here before. Binary.read. Looks like we've got some pretty. It's quite more significant than we had previously seen here, right? This is 16 samples. If we go back here, 16 out of 515, right? 16 divided by 515. We've got about 3% or so.
Yeah, exactly. That's what I looked up earlier as well. You can actually find it in the on the left-hand side. I think it's in the parser.
Yeah.
In the 3. Yeah, exactly. You can.
Yeah, I see what you mean. You mean if we undo this? It's
if you don't filter. Yeah, exactly.
There's something.
Left.
Start, parse.
Start, parse, decode. Then there's like a 3-4 decode.
3-4 decode.
And then. Yeah, and then it's like the monitor. You need to hover like the next lines. No, it needs to be.
Here we go. Yeah, here it says. Probably something that we should implement in the product, right? That we can see the comparison of this. That we see the 3.16% if we do this filtering, right? You know what I mean? Like it should just tell us that this is 3 point something out of the total data, right?
Like now it gives us the relative to this filtered version, but we are more interested in like the percentage that is in the absolute sense that like the overall profiles had.
Exactly.
500 or something samples, and this is like 3% out of this.
Exactly. Yeah. All right. So yeah, we'll undo this. If someone wants a quick contribution to the Cilium project. You now know what to do. Probably you'll be able to reduce memory usage by Cilium a little bit. All right, let's get rid of our profiling data here. We've already persisted it into our commit message. We've got a clean working directory as well. Again, now let's have a look at that second function, data path trace again. We'll do this exactly the same thing, I would say. Let's start out with extracting decode, trace, notify version 1. We've got data as a byte slice. And we'll start out again with exactly this. Tn is trace. What does, no, now GitHub Copilot is too eager to repeat what we've done previously. Oops. So now we've extracted this again. We'll replace our usage again here. So we'll do, yeah, decode, trace, notify version 1. No, I don't know why it wants to keep doing this. We want to pass version 1, which it is. However, this is like a type. It's not a type alias. It's like boxing, or I forget what the right word is in Go. But essentially, this is the same type, right? So what we can do is pass that over. Is trace notify v1, and next time if this trace notify type is changed, this will even give people a compiler error. So hopefully we'll do people a favor here. Let's see, what is this? Cannot convert variable. Is this possible? Can you do this? I guess not. Cannot convert tn variable. I guess Copilot actually wanted to do the right thing.
Kind of unpack it in a way.
Yeah, it wanted to unpack. Yeah. Ah, okay. It's just written slightly different. So I wanted to do the right thing. Wasn't sure about the syntax. So okay, cool.
It definitely doesn't look a lot like Go.
No.
At least not the way it usually looks.
Does not look very natural. All right. Let's write that benchmark again. Exactly the same methodology. I think, of course, we need to call the correct function. Good. And we pass tn here. All right. Just lazy with typing. All right. We'll do this exactly the same way again. Old.txt. To test our baseline. All right, we've got something in the same realm that we had for the other function, and now it's going to be actually a little bit less code than last time. because we can reuse the decode function that we've just written, because this is an embedded struct, right? We can start with if error unequal. Oh, sorry, error. Yeah, exactly. This is what I wanted. And then we can return error and close this. And then we do an if. Does GitHub Copilot know something here that we don't? Does this thing already exist? Oh gosh. Okay. GitHub Copilot was much smarter than us.
That's funny.
It knew. That's kind of cool. I like that. Because it probably analyzed the entire repository, it knew, or at least this entire file, it knew about this constant, and so it could use it. And I'm completely new to this code base, so it's quite likely that I would miss something like this, right? Like I did. So that's actually pretty cool. I like that. Hopefully it has the same effect. For a moment, let's use 48 then. Just so we can kind of test our theory, right? That when we change it to the constant, that will have exactly the same result. I don't see any reason why not. I just wanna be scientific about it. All right. What is different about V1 compared to the other ones? It's 16 bytes longer, and it's just an IPv6 IP. We had what was it? Now I can look at this. It was 32. Yeah, okay, so this makes perfect sense, right? We had 32 bytes before, and this has 16 bytes additional, so we're at 48. And now we can just read these additional bytes into the
so V1 is like the same as version 0. It just adds IPv6 support.
It looks like it. So GitHub Copilot again did exactly what I wanted to do here. What we can do, because this is a constant size byte slice, right? This is again something where the Go compiler can know exactly the size of memory to allocate. So this is again something that would happen on the stack, or at least it doesn't need to perform any extra allocations. And what we can just do is copy exactly the bytes from our data byte slice directly over to our target IPv6 16 bytes. Okay, I think we should already be done.
That was easier than expected.
Am I missing something? I don't think so.
No.
Let's run. You know what? We were so fast with this, we didn't even commit the benchmark individually this time. Bad habits, but it happens.
It happened.
All right, so let's compare our before and after again. And I mean, this is unsurprising, right? We have a slightly larger struct with the same wins as we had previously, again, where we removed all the allocations. And you know, we have one additional field which we also made slightly faster. So the allocation itself was even smaller. That you know, before we had 3 allocations, but which was the same as with the first function that we did, but this one was a larger allocation, and so therefore we have an even faster or an even larger improvement here. All right. Is there anything else for us left to do? I guess we should do exactly the same thing as we did previously with attaching this function to this, to the type. Actually, no, exactly, to the type. Let's copy this. Go to trace notify v1 and do that. Tn trace notify v1, and we can remove that. And I think we are. I think now we might not even need this type cast. Is it a cast type? It's not a type assertion. It might be a cast. Not 100% sure about the
I think you're
terminology.
right. Yeah, I think typecast is correct. Yeah. So
it says it has no.
That looks a lot cleaner.
No field or method. No, it says that this doesn't work.
Oh, okay. My stream's behind.
That's interesting. Why is that? Did we not name it correctly? Decode trace. Huh.
Do you need to do like the tn.trace notify v1 dot decode? I mean, that's what the casting was for, right?
I'm guessing we do have to. So what was it? Trace notify v1. Oh, and well, we probably need to put this into parentheses again as well. Yeah, and now this does work. Wow, interesting. All right.
Didn't really make it less complicated on this part.
Why does that work up here though? Perhaps someone in chat sees it?
I guess because TN already is. I mean, it definitely has to be a version 0 at this point, the TN, right? Whereas the other one, I guess it can be either or, like the version 1 or the one without versioning. So we need to make sure it's the exact thing we want, which is the notify v1 version of this. But we aren't really typecast, like the switch isn't really on the dot type, right?
No, yeah, it's not on the
That's
type,
weird.
It's on what's read from this. And funnily enough, here binary.read was not used. Let's try this again. I'm actually, I feel like we're missing something obvious. Trace notify has no field or method. Decode trace notify version 1. And
can you do tn dot trace notify version 1 dot decode? Does that work?
Okay. tn dot trace notify version 1. No, I mean, this makes sense that this doesn't work. Interesting. I suppose we're gonna leave it like this, unless anyone in chat sees what can be done differently. I would say we leave it like this.
Let's leave it like this, but yeah, if anyone has a different idea, put it in chat.
Yeah. All right. Let's adapt our benchmark again. So we've got TN. Should we? Oh, no, this is correct. What I was kind of thinking about is should we maybe have a function separately for the for this raw type, right? Like where we don't know which one it is. But I suppose that's exactly what this function is, right?
Yeah, exactly. Yeah.
So
just the switch, basically. Yeah.
So I think we're good. All right, let's do a comparison with and without that constant. I don't see why the constant wouldn't be able to do exactly the same thing, but let's just run this benchmark one more time.
I guess in this case, it would be interesting to look at the assembly if like the constant will be kind of like substituted in the assembly the same way the 48 would be in the assembly that we would type directly into the source. Like byte by byte, it should probably end up the same in assembly.
Yeah.
But
let's
just assumptions.
One more time. Yeah, we're still at our 95% improvement. And now let's do that replacement with the constant. So if we go into this function and we replace the raw 48 with exactly this constant.
If we're at it, you can already do the one above, I guess. If we prove it for this version 0 should be the same. Okay, you were faster than the live stream again. So.
Sorry about that.
All good. It's just physics, I guess.
Yeah, looks like it's exactly the same. 94 point some 0.5 something. This is unchanged. And in any case, I think even if there was a tiny change, we would probably prefer the readability of this constant over
yeah, definitely
over such a tiny improvement. We're in the low nanoseconds at this point. There's not much to gain here anymore, probably. Trace notified. Yeah. Although this one we should maybe add into another commit. So let's do a commit. Let's copy this. Actually, we can probably copy the commit message from the previous commit. Let's do that. We put work into this one already as well. So get div data test. Okay, we can just fully commit this, and then we're gonna partially remove that. This is the one thing that we don't want to do. Yep, we want that, and we want that. And now we're gonna commit. And whoops. Improve performance of trace notify decoding trace notify v1. Previously decoding trace notify v1. Perform 3 unnecessary allocations. This patch removes these allocations, resulting in a 94% reduction in runtime performance, and the exact one is up here. I'm going to copy that and insert it underneath this old benchmark from the previous function. And I think we're good. So let's commit this. Now we can remove our
minus 100% on locations. That's always nice to see.
yeah.
Best case scenario.
It's one of those, one of those sayings in performance optimizations. Not doing something is always faster than doing something, right? And with memory allocations, that's of course especially true. All right.
Yeah, and like I kind of wasn't aware of how much like memory allocations actually also spent in CPU cycles, like until like a year or two ago. Like that was like kind of eye-opening once I realized that. Like if you reduce allocations, like CPU also drops quite significant usually. It makes sense, like thinking about it now, it 100% makes sense, but you wouldn't like make that direct connection.
All right. I added the constant to the other commit. What's left to do?
Open the PR, I guess.
Should we?
I don't know if we can. Yeah, sorry.
I was just gonna say maybe we can have a quick look at how benchmarks are usually written in this framework. It looks like, whoops, it looks like there is precedence in the payload suite. So it seems like if we attach this benchmark function and just like with the other benchmarks, just call it, prefix it with benchmark, it should probably work the same way. And we use C in the same way as we would use the B here. So let's do that. Data path trace testing. So looks like there's actually already a correctness test. So it looks like we don't need to write any correctness tests for this. That's great.
Nice.
So we can just copy this monitor suite, prepend it to this.
It's kind of funny though,
benchmark.
the correctness test just decodes all 0 bytes.
Yeah.
Good enough.
Was it just C? So that must mean that C is defined in this. What? Oh, it's
because they do the dot.
I'm not a huge fan of that, but I'm sure it's a well-known pattern. Just never worked with this library. We'll roll with it. Okay, then I guess this doesn't work. I think I saw something about assert. Assert is nil for errors. So can do that here and here, and we can remove this. Remove this. Remove the fatal. This. Remove this. Again, remove the fatal. C.assert undefined C. Okay, we need to, of course, still do the same thing here. Oops. Need to get it into my buffer again. Now, we and the pointer to C. And we do report Alex here as well. It does not like that. Okay.
Yeah. Let me check.
Report. Looks like it does not expose this, at least not in this file. I suppose we can remove it. We know
Maybe
for sure.
automatically does that. Let's see.
Maybe it does.
Mm. No, I can't find anything about allocations in the source of the check. Benchmark go file.
All right. I think.
Oh, yeah.
I think we're done. Let's just run all tests. Does that mean it will run the benchmarks as well? Yeah, no, it doesn't. That would have been surprising to me. But if I now do bench dot, will that run the benchmarks? Now I'm curious about this.
Yeah. How do you actually execute those?
How do I then run this? Perhaps someone in the chat knows?
The README doesn't say. Looking, yeah, in the same docs. No idea. There's a Labix org, like their own hosted website that has more documentation. They should like at least like link from the README to this one. Skipping tests, running tests, go test.
Okay, it says using the check B flag.
B flag. Yeah. That is interesting.
All right. I mean, I feel like I think we've done our duty.
Yeah.
So, I'm just going to commit this as a separate commit. And say package monitor convert standard go benchmark to check. Is it check.in or
go package.in/check.
I guess it's go check to go check. Let's do that.
Yeah.
All right. Actually, let me do something. I want to add you as a co-committer to these. Do you happen to know?
Don't worry.
All right.
No, I don't, but it doesn't matter.
It will probably take as long writing these benchmarks. All right, let's push it. Right. I actually haven't forked. So Cilium.
Isn't it
look,
Cilium eBPF?
We know this guy. Hey, hopefully Casey sees us.
Yeah.
On the
what's up, Casey?
On the stream. For context, we used to work with Casey. Gosh. I already have.
Isn't it the eBPF package though?
Was it? No, this one was not.
Okay.
But apparently I already have a fork of Cilium. I had no idea. Do I already have it here? No, that's interesting. Okay, git remote add. I guess that must be this then. Is that right? That is correct. This is even recent. When? Oh, you know what? I added ourselves to the users list earlier today. And that's
Earlier
probably
today.
that's probably what happened. So git at github.com / Cilium. Oops, what did I do wrong? I need a name. First time contributors, I am. Fork the Cilium repository, push your changes, submit the pull request. Takes some time. Okay, we'll do that in a second. Each commit must compile and be functional on its own. We made sure about that. All code is covered by unit and or runtime tests that we made sure as well. All changes have been tested and checked for regressions by running existing test suite against your changes. We've done that. See the end-to-end testing framework for additional details. I suppose we've ensured that there is a correctness test for the function, so I think we can just have hopefully CI run some end-to-end tests. I wouldn't expect there to be anything. All commits contain a well-written commit message. We did make sure about this. If any of the commits fixes a particular commit, what fixes a particular commit already in the tree that commit is referenced? Okay. We do not have that case. If you change CLR arguments, we do not. All commits are signed off. Oh gosh, I did not do that.
But yeah, maybe they give you can rebase and then it will.
I can just
sign it off.
I'm copying it from the contribution I did earlier.
Yeah.
So how many commits did we have again? We had, whoops, git log.
Or maybe.
Yeah, git repo slash hit 4. Edit each of them. Git commit.
You should be. I think there's an option to say
here it is.
Amend and sign off or something.
Yep.
And then it will automatically put the thing there. Yeah. Okay, that's what you're doing.
That's funky. I also expected that to work. Here it says lowercase. Let's give that a try. There we go. Okay.
Oh yeah. Nice. Every time I contribute to Prometheus.
Yeah, same. All right. We've done this as well. Document and user-facing changes. We do not have that optional. Pick the appropriate milestone. I'm gonna leave that up to the team to do this. I do not have any permissions. I'm gonna skip over this. Verify this is just a performance improvement. I'm gonna skip a release note for the moment, but perhaps someone wants us to include maybe like an enhancement or something. But I'll leave that up to the PR reviewer to tell us if they want us to do that. Open a draft. I think we're good. We've been pretty diligent with our changes. Okay, I think we're good. It's not a super large one. Okay, we've done that. All code is covered. Yep. We have done that. All commits contain well-written commit messages. They do. If your commit description contains, it does not, then please add. I guess I'll say this applies. All commits are signed off. Yes. Provide a title or release note blurb suitable for the release notes. That's all right. I'm gonna just add something here. Reduce CPU cycles. Used. Or how do we say? Let's express something along the lines of that we've seen this in the real world, right? And it was about 3 to 4% of CPU time of Cilium installed. Reduce CPU cycles.
I mean, reduce CPU cycles by getting rid of all allocations, reducing.
I mean, release notes we want to be user facing, right? Like what does the user care that it was allocations, right? The user doesn't care. Reduce CPU cycles.
By 3%.
By 3%.
By overall, yeah.
In long running, by 3% baseline.
And continuously profiled Cilium.
Cilium workloads.
Workloads, yeah.
Let's do that. We're not fixing anything, but we've added a. I guess we can use the same thing. And I'm gonna say see each commit message for the detailed description, but these patches reduce the baseline CPU usage of Cilium agents. That's what it was called. By 3 to 4%. By removing allocations. The decode functions themselves improved in runtime by 92 to 95%. All right. Here I gotta echo functions. All right. What do you think? Are we ready to open this?
Yeah, I think very much so. Let's go.
Super cool. Oh, actually, we've done this now as well. All right. Very cool. I guess in a future, what? Does not contain? Ah, I did not push again.
Now we get the force push. GitHub update.
Oh no.
That's fine.
The GitHub release will.
It's not perfectly clean.
It says still does not. What?
That is weird.
That's odd. No, they do.
Signed off by. It just says signed off. No, it says
signed off by.
Okay, interesting.
Huh.
maybe they can provide us with some feedback on the PR on how to fix that, because yeah, I don't see what's wrong either right now.
It seems that the bot hasn't noticed. Oh, we've got action on our pull request already. It seems that the bot hasn't picked up the force push that added the sign off to the credits. Any suggestions how we could fix that? All right, super cool. That was really fun. Let's see. Curious what chat has to say. Whoops.
I was quiet the entire time. I would have said.
Yeah, I think that was super fun. I mean, you know, if we manage to improve all Cilium installed by 3 to 4% baseline, I think we've made a pretty real impact on the world today, right? Like, this is a piece of software that by now I think it's pretty much become the default networking solution in Kubernetes clusters. So if we manage to reduce every single Kubernetes cluster by some amount of CPU, I think we've done something real today.
Yeah, definitely agree. Nice.
Cool. Anything else you think we should check out?
Yeah, just missing the closure of deploying compare. Yeah, I guess there's no easy way to deploy this to production and like build the image and all of that. So I guess that would be easy if we were the ones deploying and running this, but this is like through all of their CI, and
yeah,
I don't even know if we can change it on a GKE cluster on Google Kubernetes engine.
Yeah, no, I don't think so.
Maybe we'll pick a workload next time where we can like have that experience.
Yeah.
Of deploying it afterwards or in between even and seeing the differences. I think that would be great. But I think this is already, I mean, we've proven it. So.
Yeah. All right, cool.
But yeah, I think, yeah, again, this is like the first installation of Let's Profile. So we'll have more of this. Let us know what software you wanna see us profile and want us to overall just improve. And then I think you can subscribe to the YouTube channel to be notified when there's more coming up. But obviously, I think most people got that through Twitter. And then we also have a Discord for both Polar Signals and Parker, the open source project. Be sure to check those out and say hi over there. Yeah, I think that's it.
Sounds good. All right. Hopefully see you all again next time. We'll see when that is. Maybe we'll make this a weekly thing, maybe a bi-weekly thing. We don't know yet. We're still figuring it out. But this was fun. Maybe someone else can drive next time. I think that'd also be cool to kind of switch it up from time to time. But yeah.
Yeah, definitely.
I had a blast. Thanks everyone for stopping by.
Thank you, Frederick. And yeah, see everybody.
All right, I'll stop the
bye-bye
stream.